maths class. Previous class we discussed about quadrilaterals. Especially we discussed the properties of a parallelogram. We studied that opposite sides, if in a quadrilateral, if opposite sides are equal, it will be a parallelogram. If opposite angles are equal, then also that will become a parallelogram. The diagonals of a quadrilateral bisect each other, then also it will be a parallelogram. Next I am saying one more property. A quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. If you are showing that opposite, suppose that we are drawing a parallelogram ABCD. If ABCD, if you can prove that AB equal to CD and AB parallel to CD, then also that will be a parallelogram. In a quadrilateral, opposite, if a pair of this AB and CD are one pair of sides, then if that are equal and parallel, if you are showing, that also will be a parallelogram. Using that property also we want to do some exercise question. Next, our important topic, the midpoint theorem. In the case of a triangle, ABC is one triangle. E is the midpoint of the side AB and F is the midpoint of the side AC, and we are joining that line EF. That line will be parallel to the third side and its length will be half of EF is equal to half BC. Its length will be half of BC and this EF will be parallel to BC. This is known as the midpoint theorem. Once again, we are drawing one triangle and we are taking the midpoint of any two sides and joining that line. That line will be parallel to the third side and its length will be half of this side BC. This is known as the midpoint theorem. This is important one. Next step, we are saying about the converse of midpoint theorem. Converse means we already studied how we can say its converse. Just look. So, suppose that in a triangle we have given E is the midpoint of the side AB and we are drawing through E, we are drawing one line. That line is parallel to BC. Then surely F will be the midpoint of AC. That is known as the converse of the midpoint theorem. Once again, that is written here, bisect the third side. Bisect means it will be equally dividing. AF is equal to FC. That means F will be the midpoint of AC. Then what is meant by converse? Suppose that we are given one midpoint of the one side is given. We are drawing one line parallel to the third side through that midpoint. Then that line surely bisect the third side, or F will be the midpoint of the midpoint of AC. This is known as the converse of the midpoint theorem. Using this we are doing some exercise questions. One question, ABCD is a quadrilateral. ABCD, PQ, R and S are the midpoint of the side AB. AB's midpoint is given P. This is the midpoint. BC, that is Q. R is the midpoint of DC and S is the midpoint of AD. And AC is a diagonal. We are joining one diagonal also. And you want to prove that SR parallel to AC and SR equal to half AC. That is the first question. So, we are joining this PQRS we joined and we want to show that PQRS is a parallelogram. That also you want to prove. For this, we first join that diagonal AC and take the triangle ADC. In triangle ADC, we know that R and S will be the midpoint of the side CD and AD. We are joining that S and R. Then AC also we joined. In the triangle ADC, by the midpoint theorem, we can say that SR parallel to AC and SR equal to half AC. That only you want to write here. In triangle ADC, S and R are the midpoint of the two sides. We are joining that. That will be parallel to AC and its length will be half AC. That only you want to write there. So in triangle SR parallel to AC and SR equal to half AC. The reason is by midpoint theorem. By midpoint theorem. So first question over. Second one, thus we can give us equation number 1. Okay. Then for proving PQ is equal to SR, you want to take the another triangle ABC. From that, what we can write? In triangle ABC, we can write PQ parallel to AC and PQ is equal to half AC. That is the equation number 2. The same reason by midpoint theorem. If you are taking ABC, the triangle, P and Q are the midpoint of the side AB and BC, and we are joining this line. This line will be parallel to the third side AC. Its length will be half of AC. Third side, that also you got. From 1 and 2, what we can write? From 1 and 2. Equation number 1, this is equation number 2. From 1 and 2, we can take that SR equal to half AC and PQ is equal to half AC. Then from 1 and 2, right side both are equal, half AC. So we can write that SR equal to PQ. Okay? SR equal to PQ you got. That only you want to, PQ is equal to SR, that we already proved. Third one, what we want to prove? From second, we already got SR equal to PQ. Then next equation look. First one, PQ parallel to AC and SR parallel to half AC. SR parallel to, SR parallel to AC, PQ also parallel to AC. Both are parallel to the same line AC. From that what we can write? PQ parallel to SR or SR parallel to PQ. From this. So we got one side, two sides are equal, one pair of sides are equal and parallel. Then we can say that PQRS is a parallelogram. In the first we told that if one pair of side of a quadrilateral are equal and parallel, that will be a parallelogram. So we got from 1 and 2, we got SR equal to PQ, and compare this one, PQ parallel to AC and SR parallel to AC. Compare PQ parallel to AC and SR parallel to AC. That is equation number 1 and 2 we already gave. Equation number 3 and equation number 4, SR parallel to AC. From 3 and 4, you got SR parallel to PQ and SR equal to PQ. So PQRS is a parallelogram. So PQRS is a parallelogram. This is our question proof. Second question, ABCD is a trapezium in which AB parallel to CD. Trapezium means you already know that one pair of side will be parallel. Here AB parallel to DC or CD is given. BD is a diagonal. E is the midpoint of AD. This is the midpoint of AD. A line drawn through E. Through E, we are drawing a line parallel to AB. This line is parallel to AB and intersecting BC at F. Intersecting this line BC at F. This is the point F. This will be the point F. You want to show that F is the midpoint of the BC. You want to show that this F will be the midpoint of BC. This is the point F. Here is the point F. This is the, you want to show that F is the midpoint of BC. Then, given that it is a trapezium given, already given AB parallel to CD. Then, let D be intersecting EF at G. This point we are marking as G. Because EF is intersecting BD at G. And in we are drawing this diagonal, then we are getting two triangles. We are taking the first triangle ABD. Already given E is the midpoint of this is the point. E will be the midpoint of AD. That is already given. And this line we are drawing is parallel to AB. That they already told that E is the midpoint of A. A line is drawn through E parallel to AB. So EF is parallel to AB. Then E is the midpoint and this line EG will be parallel to AB. Then what we can write? G will be the midpoint of the side BC by the side BD by the converse of the midpoint theorem. You know that what is the converse? One side, this is the midpoint given. This line is parallel to this third side. Then automatically G will be the midpoint of the third side. So we get now G is the midpoint of the side BD by the converse of the midpoint theorem. Next we got G is the midpoint theorem. Next we are taking the another triangle BDC. In that triangle we got G is the midpoint of the BD and this line GF will be parallel to DC. So F will be the midpoint of BC by the converse of the midpoint theorem. You already know that AB parallel to CD. That is already given there. This drawn line EF that parallel to AB. This drawn line will be parallel to AB. So this EF also will be parallel to AB. EF will be parallel to DC or CD also. This is the condition. AB parallel to CD. This EF will be parallel to AB. Automatically this line will be parallel to CD also. Then we can write that G is the midpoint of BD and GF parallel to DC. So F will be the midpoint of the side BC by the converse of the midpoint theorem. So F is the midpoint of the BC. We already proved. In a parallelogram ABCD, E and F are the midpoints of the side AB and CD. AB's midpoint is given E and DC's midpoint is given F. Show that the line segment AF, this line segment AF and EC trisect the diagonal BD. What does mean by trisect? Trisect means three equal parts. This lines dividing that diagonal into three equal parts. Or we need to show that DP is equal to PQ is equal to BQ. For this, first we are going to prove that AECF is a parallelogram. We studied that one pair of sides are equal and parallel, then that will be a parallelogram. For this, AB parallel to CD, that we already know that it is a parallelogram. So AB parallel to CD. Its midpoint is E. So AE also will be parallel to CF. Its midpoint is given. Then AB equal to CD, the same case opposite sides of a parallelogram are equal. Then AE means half of AB, FC means half of DC because they are given E is the midpoint. Then we got AE equal to CF. Then from 1 and 2 we know that AECF is a parallelogram. So EC also parallel to EF. AECF is a parallelogram you got. Then we are writing that AF parallel to CE, AF parallel to EC. That also we have written. Next one, we are taking the triangle DQC. We are taking the triangle DQC. Taking the triangle DQC. In that we already know that F is the midpoint of DC and this line is parallel to CQ. So we can say that P will be the midpoint of DQ. Then we can write DP is equal to PQ by the converse of the midpoint theorem. Next we are taking the triangle ABP. ABP. From that also we know that E is the midpoint of AB. This line is parallel to AP. So Q will be the midpoint of the side DP. That means DP BQ is equal to PQ. That we are writing as equation number 2. Equation number 4, dp is equal to pq, you have written 3. From 3 and 4, we can say that dp is equal to pq is equal to q. dp is equal to pq is equal to qb or bq. That means this line trisect the diagonal BD. Next question, ABC is a triangle right angle at C. At C, it is 90 degree. A line through the midpoint M of hypotenuse. AB is the hypotenuse, M is the midpoint of AB. Parallel to BC, we are drawing a line through M and parallel to BC. MD we are drawing, that line will be parallel to BC. Intersect AC at D, show that D is the midpoint of AC. First you want to show that D is the midpoint of AC. What are things given? M is the midpoint of AB and we are drawing one line MD that will be parallel to BC. So D will be the midpoint of AC by the converse of midpoint theorem. That only you want to write for the first question. Second one, MD perpendicular to AC. Here both sides forming 90 degree, that is angle ADM is equal to angle CDM is equal to 90 degree you want to show for the second question. For this, MD parallel, these two lines are parallel, that you already, MD parallel to BC and AC is a transversal. Then these two angles will be angle ADM and angle ACB. That two angles will be corresponding angles because we knows that these two are the parallel lines which is cutting by a transversal. These two will be the corresponding angles. The same way, DM parallel to BC and AC is a transversal. Angle ADM and angle ACB. Angle ADM is equal to angle ACM. That is corresponding angles. ACB they already given 90 degree. So ADM also 90 degree. That means MD this line is perpendicular to AC. Third question, you want to show that CM is equal to MA is equal to half AB. CM is equal to, this is CM. CM is equal to AM or MA, that is equal to half AB. What do you want to prove? That CM is equal to AM. First you want to prove that. For this, these two triangles we are going to prove congruent. Then by CPCT we can show that CM is equal to AM. For this, these two are the linear pair. Angle ADM plus angle CDM is equal to 180 degree, that is linear pair. Each angle ADM is equal to CDM is equal to 90 degree. Here already proved that ADM is 90 degree. So this angle also will be 90 degree. In triangle, next we are going to prove these two triangles are congruent. Here these two angles are 90 degree and D is the midpoint of AC. So AD is equal to CD. Then DM is equal to DM, that will be the common side. By SAS rule, these two triangles are congruent. By CPCT we can write AM is equal to CM by CPCT. Then you already knows that M is the midpoint of EP. So AM is equal to half EB. So we can write AM is equal to CM is equal to half EB. This is our proof. Okay children, we can meet on the next class.